Alright, now it's time to start working with our double angle formulas. So many of these problems will be phrased like this example that we're going to do now, in which you know something about your angle without knowing exactly what your angle is, but you're interested in a feature of 2 times your angle. So if you knew you were dealing with perhaps a pi/6 angle, then you're interested in some feature about a pi/3 angle, but we have to pretend we don't really know that. So here's a perfectly random example. We want to know what the sine of the double angle is if we know that of our single angle, the cosine is 5/13 and the angle is in quadrant 4. So I don't have an identity or don't have a basic identity I can use here, and I don't know any algebra to get me this. Do not, please, multiply 5/13 by 2. That will not work. So we're going to have to pull out and dust off this sine of 2 theta formula. And the sine of 2 theta equals 2 times the sine of theta times cosine of theta. Now, in order to use this formula, we need to know more than just cosine of theta. We also need to know what sine of theta is, but we have a method for getting that. Since sine and cosine will fit the identity that sine squared plus cosine squared equals 1, we can exploit this fact and fill in what we know to figure out our unknown variable. So I put 5/13 in for cosine, and now I'm going to need to square it. After I square it, I need to get sine squared alone by subtracting 25 169ths from both sides, leaving me with 144 169ths, and I take the square root of both sides to find out that sine of x is equal to 12/13. Now that I know sine of x and cosine of x, I'm well equipped to work out this problem. Now, since we're in the 4th quadrant, sine needs to be negative. Alright, so back to the formula here on the left. I'm going to have 2 times negative 12/13 times the cosine of theta, which is 5/13. Now this is going to simplify to negative 120 169ths, and this would be the y variable for the wrapping function value for whatever angle is twice our original angle. While we're here, let's go ahead and calculate cosine of 2 theta and tangent of 2 theta for practice. Now, you know that we already know what sine and cosine are, so this makes our job a little bit easier. Cosine of 2 theta is equal to 3 different things, and it's completely arbitrary which one you use, so this time I'm just using 2 cosine squared theta minus 1. Notice this doesn't rely on knowing sine of theta, so if I had broached this one in the original, I would not have needed to calculate sine of theta. But this is 2 times the cosine squared, which is 25 169ths minus 1, which is going to be negative 119 169ths. And then remember, there are 3 ways to exploit or to use cosine of 2 theta. Now let's do tangent of 2 theta. This is 2 tangent theta divided by 1 minus tangent squared theta. Now, tangent theta is, of course, sine theta divided by cosine theta, so this is going to be negative 12/5 divided by 1 minus 144 divided by 25, which is, of course, negative 12/5 squared. If you simplify, this will bring you to 120 119ths. So your job, the only little job you need to do tonight besides study, is see if you can get that to simplify. And I'll give you a hint. When you multiply by a factor of 1, it should be the greatest of the denominators that you are trying to eliminate. Now, you've done all this fancy work, it's a lot of simplification, you're not sure if it's right. How can you know that this 120 divided by 119 is correct without going back and relying on all of your fancy footwork and simplification in the tangent to theta formula?